In this video, we'll learn how to use a potentiometer to control a servo. A potentiometer is a variable resistor, and by turning the knob there, we can change the output signal going to Arduino and therefore control the direction of the servo. In this particular potentiometer, it's a B100K, where B stands for linear, 100 stands for 100, and K stands for 1000 ohms. So we have a 100,000 ohm resistor here. Now we could use a 10,000 ohms or 5,000 ohms or even 1,000 ohms. I've tried all of them and they all work fine. It's important though to use a linear potentiometer though. It may give you some funny results if you use an exponential one. So what we have here are 3 leads going out, and the middle lead there, the one which is white, it goes to one of your analog inputs, so A1 to A5 or A0 to A5. Now as for the 2 side leads, one there in black, one in brown, these ones can go to either the ground or to VCC. So the black one could go to ground, the brown one can go to VCC, or the other way around. The black one goes to VCC or the brown one goes to ground. It doesn't quite matter. So if you don't like how things are turning when you adjust the servo, you just swap the leads around. Now because I will power both the potentiometer and the servo, I'll use a breadboard to be the base of my power supply to both modules or devices. So I'll stick to convention. I'll use red for positive from VCC or 5 volts, and I'll use black for negative, which is ground. So let's connect those up now. So here's my Arduino board. Let's find the 5 volt, which is over here, and I connect my red one first, and now I connect my ground, my black lead, and here's a spot over here. There. So there it is, 5 volts and ground. Now the other end of the leads, my DuPont leads, just keep in mind that with our breadboard here, every row with my fingers pointing is electrically connected. So anything connected to the same row of pins will be connected to anything else on that same row of pins. If you look at the back, you can actually see the conductors. So that's how it works. So I'll connect my red over to one row here, over there, and my black can be somewhere else over here. There we are. Alright. Now to connect the potentiometer. So remember that the white lead there goes to analog input, and the black and grey goes to respectively ground and positive. So here we go. Black goes to black. Yep. Grey is my positive, so it will go to the red one over there. There's grey. And the white one goes to an analog input, and I'll choose A0. So that's how it looks so far. Okay, time to connect the servo to the breadboard. So what I've done here to make life easier for me, because the output from the servo is a female connection, to connect to the breadboard I've attached some male to male leads. So male goes to female, and now male goes to here. So just remember that red is always positive. Okay, so I'll put red to red. From the servo here, brown is negative, or to ground, whatever. So I put brown to ground there. And I'll connect the signal lead, here shown in orange, to a digital pin, let's say 3. So that's how things are wired up now. Now here it is all connected. So the breadboard and the potentiometer and the servo to Arduino. It's all powered now. Time to upload. So make sure that when you do this, you go to tools first. Check that you're using the right board. So it's Uno. I'm using Uno. And also make sure the right ports. So if you see this coming up here, detects the board, so choose that one. And then to make sure it's all working fine and connecting okay, get board info, and you should get a pop-up. So you see a pop-up like that, you can upload to your board. Now it's time to compile and upload. And it's uploading now, and done uploading. So here we are. And let's try this. Put that closer together. And let's see how this works. So we'll see that it's turning in response to me turning the potentiometer. So what I've done in my code, I've broken down the intervals of rotation into 9 steps. You don't have to do that, I've just done that. And so you can be just incremental, very, very gradual, or in steps like I've done here. So here's the code. So make sure you include the library for the servo. There's a command there, include servo.h. I've identified some variables for my pins. So for pin A0, which is the analog pin going to the potentiometer, I've given the variable name of pin potentiometer. And for the servo pin, I've set to pin 3 on the digital line there. So there's a 0 there for the potentiometer, and there's pin 3 for the servo. So make sure you declare an object. I've called my servo object my rudder, and I've commenced the serial monitor so we can see the output. And I've attached the my rudder to pin 3. That's what that command does there. And for the code here, I've just made things a bit more complicated than maybe they can need to be, but anyway, it's very simple. So this line here, we declare a variable to read the raw output from the potentiometer. We call that raw output raw rudder, and then we show that on the serial monitor. In this line here, we convert that value, which ranges from 0 to 1023, into a value from 0 to 9, or 1 to 9, or 1 to 10, whatever. So, and then we show the value on the serial monitor down here, and then here we basically tell the servo to rotate to the angle of rudder multiplied by 18 to give us degrees. Now keep in mind with the servo, you can adjust the position of the arm here. So if you don't like it where it is, you just take it out and just put it back.